Welcome to section 2.6, operations and composition of functions. So let's take a look at some of the main operations. Again, hopefully you've seen this before a little bit, but if not, again, don't worry. So again, if we're talking about two functions, f and g, we can do addition of those two by combining f of x plus g of x. We could do subtraction, and then f of x minus g of x. You can do multiplication, and then f times g. And lastly, you can do division. However, careful with division. Because we have g of x in the denominator, remember, we cannot have 0 in the denominator, so g of x cannot equal 0. And then because we're combining functions, we wonder what the domain is going to be of those two functions. For addition, our domain is going to be the intersection. Pretty much they're all going to be the intersection, except for the division. It is the intersection, however, we have to take out where a denominator is 0. So that's the one thing. Other than that, it's always the intersection of the two different functions' domains. Alright, so let's go ahead and take a look at some operations. So we're given f of x is the square root of 4 minus x, and we're given that g of x is negative 2x plus 5. And we're trying to figure out f plus g of x. Oh, sorry, f plus g of 4. Which means we're going to be inputting 4 into our functions. So let's see, I'll go ahead and try color coding this. This is going to be 4 minus, and my input is 4, plus, because again that was the f function, now we're going to do g function, which is negative 2 times my input plus 5, and again my input is 4. Simplifying this out, that's going to be the square root of 0 plus negative 8 minus, or let's see, that's going to be negative 8 plus 5, which in total is going to be negative 3. Alright, let's go ahead and look at the next one. The next one is going to be subtraction with an input of negative 5. So again, using the same function we've been using, square root of 4 minus the input of x. This time it's going to be minus. And then negative 2 times their input plus 5. And again, our input is negative 5. So simplifying that, that's going to be the square root of 9 minus, let's see, 15. So square root of 9 is 3, minus 15 is going to be negative 12. All right, and then moving along, what do we have here? Okay, now we have subtraction. This time g is first. And again, with subtraction, you have to keep the order, the first one minus the second one. And then our input of negative 5. So this time g is first, so that's going to be negative 2 times my input plus 5. Again, we're doing subtraction. And then my f value, square root of 4 minus my input. And my input, again, is negative 5. So calculating that all out, that is going to give me, let's see, 10 plus 5 minus the square root of 9. It's going to be 15 minus 3. Which is 12. Okay, so now moving along, we have f. Now there's no symbol on the inside, which means this is going to be f times 3, or f times g, sorry, f times g of 4. So again, my f function is going to be the square root of 4 minus my input. Again, I'm always just changing my input value with whatever is given on the inside here. Let me color that red. And multiplication, so I'm just going to go ahead and keep my parentheses. Minus 2 times whatever my input is, plus 5. 4 and 4, again, is my input. So that's going to be 0, or square root of 0, which is just going to be 0, times negative 8 plus 5, which is negative 3, which is going to be 0. All right, moving on. Now we have f divided by 3. So let's see, f divided by 3, f is going to be on the top. So you have to be careful. When it's given like that, the top function needs to stay on the top, bottom function stays on the bottom. So that's going to be f of 3, which again, if you wanted to show the breaking up notation, that's going to be f of 3 divided by g of 3. And then f of 3 is going to be the square root of 4 minus my input, which is 3, divided by my g value, which is negative 2 plus 5, and my input is 3. So calculating this out, that's going to be the square root of 1 over -1, which is just going to simplify to -1. And then let's see, f. F is going to be, this time, g divided by f. So again, this is going to be g of 4 divided by f of 4, which is going to end up equaling, let's see, g of 4 is -2 times my input divided by 5, so 4, divided by my f value, so square root of 4 minus my input, which is 4. Let's see, that's going to be -8 plus 5 divided by, ooh, that's going to be 0. Can we divide by 0? No, there's no definition for that. That's undefined. So my answer is going to be undefined. Okay, and then backing up again real quick on each of these. Again, you can always split these up into this, the notation given above, like that, where this would be g of -5 minus f of -5. This would be f of 4 times g of 4. This would be f of 4 plus g of 4. And this would be f of -5 minus g of -5. Again, you can split that up or you can skip that step. If it's easier to see how the problem works out by doing that step, awesome, go ahead and do that. So let's take a look at example 2. We're going to use the graph to evaluate each expression. Again, we have different operations going on: addition, subtraction, multiplication, division, and again, addition. And we have input values. Remember, these input values are always my x value. And then when we find my function, I'm solving for my y value. So we're basically given x and we're trying to find the y value, or the corresponding or matching y value. So this time I'm going to go ahead and split these up. We're looking for f of 3, and then we're going to add to that g of 3. So let's go ahead and look at our graph. Again, these are our x values, and we're trying to find the matching y value. So when f is equal to 3, what is the matching y? So at 3, f is here, and the matching y is 2. So we're going to go ahead and plug in 2 plus. And then for g, at 3, what is g? G is over here, and the matching value for that is 1. Again, so it's at 3, 1. So it's going to be plus 1. So that'll equal 3. So again, our input is our x value. We're going to look around the graph for the matching or corresponding y. So the next one, this is going to equal, now this time g is first, so that's going to be g of 0 minus f of 0. And what's that going to be? Well, let's see, g of 0. At 0, g is down here at -2. Minus, use our parentheses here to be careful. At 0, f is 1 again. Not 1 again, f is 1. So that's going to be -2 minus 1, which is -3. Okay, now let's move on to the multiplication. This is going to be f of 3 times g of 3. And we've already found f of 3 and g of 3. We found that in the first part over here. So f of 3 was 2, and g of 3 was 1. So that's just going to be 2. Okay, so now we have f of 0 and g of 0. Careful, it's not undefined, even though you see 0 in the denominator. Again, it's if my y value is 0, that's when it's undefined. So for now, we're okay, unless g of 0 becomes 0. So f of 0, at 0, f, again, we found that out, is 1. And then at 0 for g, g of 0, we found out was -2 down here. So that would be just -0.5. All right, so again, moving on. Now we have addition. So this is going to be f of -1 plus g of -1. And that's going to equal, let's see, f of -1. We haven't found that yet. So at the point -1, f is going to be, this is -1, 0. And then for g of, oh wait, g doesn't have a -1 value along here. G doesn't have one. So what would that mean if our g value does not have a corresponding value down there? We have 0 plus, there's no value for g. It's undefined. Well, because there's no value for g, it's undefined, this is just going to end up being an undefined problem. So our answer is going to be undefined. Because again, there is no corresponding value for an x value of -1 for g. It stops over here at x is 0. Nothing past it on this side. All right, so let's go ahead and keep moving on. Now let's take a look at example 3. We're given two functions, f of x and g of x, and we're told to find, let's see, what are we told to find? F plus g, f minus g, f times g, and f divided by g, and their domains. And again, remember, the domains are pretty much always the intersection of the original function's domains, except for this one, where we have to make sure that g is not 0. So before we do that, let's go ahead and just find the domains real quick. So the domain of f of x, I always ask myself, when I graph f of x, what would it look like? Well, this is just going to be a line, a slanted line. And the domain for slanted lines is, again, -infinity to +infinity. And then g of x. What kind of function is g of x? G of x is, again, a line like f. So the domain for g of x is just going to be, again, -infinity to +infinity. Okay, so we found the domains. Let's go ahead and move on to find the next parts. Let's do the addition. F plus g of x. So this time we don't have an input number for x. We're just given generic x, but that's okay. We can go ahead and just still do the same process as we did before. So again, I'll let f be red, and I'll let g be blue. So this is going to be f of x plus g of x, which is going to be, let's see, 3x minus 2 plus 5x plus 9. And then we can go ahead and add like terms, and that's going to be 8x plus 7. So there we have f plus g of x. What is the domain? Well, again, it's just the intersection of the two domains. So the intersection of these two is just going to be all real numbers again, -infinity to +infinity, or all real numbers. All right, let's go ahead and move on to f minus g of x. Again, we'll go ahead and split that up to f of x minus g of x. Same process going down. This time we're just going to be subtracting, though. So we have to be careful. Please make sure to use parentheses. That's a great way to not lose track of signs. I do that now and then. Signs are little tricky things. Okay, so that's going to be 3x minus 5x, and then -2 minus 9. So that's going to come out to -2x, let's see, minus 11. And what's the domain of that? Well, the domain of f minus g of x is going to be, again, just the intersection of the two previous ones. So same as above, -infinity to +infinity. All right, halfway there. Now we're going to do the multiplication. So let's see, f times g of x. What's that going to be? So again, f of x, g of x. Just multiplying them out. So f is, again, 3x minus 2. Let me make that equal sign a little more noticeable. 3x minus 2 times 5x plus 9. What do we do for this? Again, we're just going to do FOIL. So if multiply the first, that's going to be 15x squared first to outside. 3x times 9, that's going to be plus 27x. Inside, -2 times 5x, so -10x. And then the last ones, -2 times 9, minus 18. Can we simplify? Yes, these two are like terms. We can go ahead and simplify, and that's going to end up equaling 15x squared, let's see, plus 17x minus 18. Okay, and we're done there. So what's the domain? Again, based on our definition at the very beginning of this lecture notes, the domain of multiplication is just going to be the intersection of the two domains, which again doesn't change. It's going to be negative infinity to positive infinity. Okay, 3 down, 1 more to go. Let's go ahead and do the division f divided by g. So again, f is on the top, so f needs to stay on the top. Don't go switching them around. And again, the thing to be careful about here is we don't want g of x to be 0, because then we'd have a 0 in the denominator, which is undefined. Plugging in the function values. Okay, so can we simplify? Well, you might be tempted to say they both have an x in the top, but again, we need to factor out that x in order to cancel it. So we can't cancel, so that's pretty much what we're left with. So now all we need to do is to find the domain. And again, the domain for the division is the intersection of the two previous domains, but what do we need to know? We just know that g of x cannot equal 0. Well, what is g of x? G of x is 5x plus 9. So let's go ahead and figure out when is g of x equal to 0. We can find that number and take it out of our domain. Let's go ahead and do that. Let's find it algebraically. We'll just set the function to 0. Solve for x. And x is not equal negative 9 over 5. So, all real numbers, because again, remember, in the beginning, our two domains were all real numbers. However, when we do the division, we have to take out the number that causes the problem. And the number that causes the problem is this number, because it makes my denominator 0. So all of the other numbers are fine. We just got to take out that value. So we'll go ahead, take it out, and continue on. Again, we use these open parentheses to indicate that it's not part of our solution. And then we're done. Again, if you need any review on combining the domains like this, just let me know and I can send you a worksheet or we can talk about it in an office hour. Okay, so moving on. This is called the difference quotients. And you'll see a little more of the use of it as you continue on in the course or in mathematics. But for now, we're just going to go ahead and learn how to play around with it. First off, notice it's called the difference because we have a subtraction sign. And then it's called the quotient because we have division or a quotient going on. Hence the name. So it's subtraction and division. Now in this, we're just using one function, f, and we're going to input x plus h and then take away the normal function. And divide it by h. And h is not a function. H is just a variable that's not equal to 0. Again, careful, h is not a function. So let's go ahead and work on this. So for the sake of this problem, I'm going to go ahead and let f of x plus h be red and f of x be blue. So my original function is blue. When I input x plus h for x, that'll be red. So again, for my difference quotient, this is going to be f of x plus h minus f of x divided by h. And again, h is not a function, just a variable. So this might look a little confusing. We're just swapping out x for x plus h. So wherever I see x, I'm going to plop in x plus h. So that's going to be 3 times my new input, again, which is x plus h, minus 1, close parentheses. And then again, we're subtracting, because again, this is the difference quotient, we're subtracting my original function, f of x, which is 3x minus 1. And then dividing by h. So again, feel free to pause the video and simplify this out, and then check in with me. Okay, so careful, we have that negative, we have to distribute that. It'll be negative 3x plus 1. So at this step, when you start to simplify, anything that does not have h should cancel in the top. So again, anything that does not have h should cancel. If it doesn't, then there might be something wrong with the simplifying. So we're left with 3h divided by h. And our h's can cancel, so we're just left with 3. Alrighty, and that was it. Let's go ahead and take a look at another example. This time we're going to use the function g of x, but the similar process happens. The first one is going to be my input with the x plus h value, and then minus my original function, g of x, which is this one, divided by h, which again is just a regular variable, not a function. So that's going to be x plus h squared, because again we take our input and then we square it, and then we plus 1 to it, minus my original function, which is just x squared plus 1. And again, divided by h. So I'm going to go ahead and have to FOIL that out. So let me write that out. That's going to be x plus h times x plus h plus 1 minus, actually I'll go ahead and distribute that. That's going to be negative x squared minus 1. So foiling out these two, again using the first outside inside last. If you need a review on how to FOIL, just let me know. That's going to end up being, let's see, x squared plus 2xh plus h squared plus 1. Again, minus x squared minus 1. Now again, at this step, anything that does not have h in the top should cancel. So the x squareds cancel, the 1's cancel, and that's it. We're left with 2xh plus h squared over h. Can we simplify? Well, notice both of these terms contain an h, so I can factor an h out and then cancel it with the 1 in the bottom. Again, you need to be able to factor in order to do the cancellation. So now they're factored, now there's multiplication going on, so I can go ahead and cancel, and that'll be 2x plus h. Okay, so let's go ahead, moving on. Now we're going to take a look at something called the composition of functions, or composite functions. So the symbol looks very similar to multiplication, however it's an open circle. That's going to be the composition of functions. What it means, you take the first one, and then you're going to input the second function inside of it. So the domain is this, is that all x in the domain of G are such that those function values are in the domain of f. So let's go ahead and do the composition. And I'll try, again, keep this color-coded so you can see what's going on. So rewriting this, this is f of g, and then my new input value is 0. So g of 0. Okay, so first I'm going to find out what g is, and then I'll input that into f. So again, g is x squared plus 5, and my new input for x is 0. So that'll be 0 squared plus 5, which is going to just be 5. So now we're trying to find f of 5. So we evaluated g first on the inside, plug that in, and we get f of 5. And then f of 5 is going to be the square root of 2 times 5 minus 1. And what's that going to be? That'll be the square root of 10 minus 1, which is the square root of 9, which is just 3. Again, if your work has to continue on elsewhere, it's good to use that arrow to let your readers know where you're going. All right, moving on to the next one. This time g is first, and we're inputting f. So this is going to be g of f of 3. So let's find f of 3 first. So f of 3, that's going to be the square root of 2 times my input minus 1. And again, my input is 3. Then that's going to be g of, let's see, calculating that, that's going to be square root of 5. So now let's go ahead and input square root of 5 into my g function. X squared plus 5. My new input is 5, or square root of 5. Then the square root cancels with that square. Continuing our work, and we have 5 plus 5, which is 10. All right, moving on. Ooh, now we have f of f. We're going to input f into itself twice. So let's see, that's going to be f of, and this time I'm going to do f of, the second f I'll do with green. But again, we're using the exact same function before. So first, let's go ahead and calculate what f of 2 is. F of 2, again, is going to be the square root of 2 times an input minus 1. So that's going to equal f of, what is that? This means square root of 3. And then inputting that, now, one more time, we're going to input it into the square root of 2 times something minus 1, and my new input, again, was square root of 3. However, I can't really simplify that, so I'm going to go ahead and just leave that as it is. All right. Now, we're going to take a look at g of 1, of negative 1. Whew, too many mistakes there. g of negative 1. And again, I'll go ahead and let the inner g be green. Let's see. So the g function, again, was the x squared plus 5. So that's going to be my x value squared plus 5. My x value this time is negative 1. So negative 1 squared plus 5 is going to be 6. And then we can go ahead. Now we're just doing one more g function. This time we have 6 for my input. And that's going to give me 6 squared plus 5, which is 36 plus 5, which is going to be 41. All right, 2 more to go. So let's see, 2 more to go. We have f of g. Ooh, my input this time is just x. Don't worry, we can still do it the same way we've been doing it before. So that'll be f of, again, we're inputting g of x. And then what is g of x? Well, g of x, again, is just the main function, x squared plus 5. And that is going to be my new x value to plug in wherever I see x for f. So that's going to be the square root of 2 times my new input, which again was x squared plus 5 minus 1. And then let's see, I can distribute that 2. So I'll get the square root of 2x squared plus 10 minus 1, which can simplify into the square root of 2x squared plus 9. However, I can't really simplify that further, so I'm going to go ahead and stop there. Now, moving on. Again, this time we have g of f of x. So g is first. So this is going to be g of, and first I'm going to go ahead and input f of x. You don't have to make the input look so dramatic. I'm just trying to give space so you guys can see what's going on. And then again, f of x is the square root of 2x minus 1. That is my new x value that I'm going to input where I usually put x for my g function. So again, my g function is x squared plus 5. So my input squared plus 5. My input this time is f of x, which is 2x minus 1. Now that square root will cancel with the square. And I'm left with 2x minus 1 plus 5. Then I can simplify the negative 1 plus 5, and that becomes 2x plus 4. Alrighty, and I am done. So if you have any questions about this section, please email me and let me know. If you need any extra worksheets, I can go ahead and give you that. Other than that, again, if you have any questions, let me know.